In this video, let's look at how to solve a basic trig equation, cosine theta equals 0. Now, when I solve this, I like to think which angle or angles have a cosine of 0, and that helps me link back to my knowledge of finding exact values. Solving an equation is a lot like that, especially one as basic as this, so you can draw on that knowledge and you're just working in the other direction, essentially. So let's go ahead and get started. Here's the outline we like to use for solving basic trig equations, and you'll notice that this one is going to be even simplified a little bit more. So in step 1, we're going to analyze, and typically we would look at what quadrants or our angles will be in, but that 0 should be a huge flag because we are not actually going to have a reference triangle. We won't have a reference angle to work with. And our angles actually aren't even going to be in quadrants. They will be on our axes, something called quadrantals, if you remember that from finding exact values. So we're going to adjust that a little bit, less analysis that we have to do, and then we'll state our angle answers. So here we go, cosine theta equals 0. Like I said, step 1, our analysis is pretty limited here, pretty simple. We really just need to think back to the unit circle, and we can think back to those special right triangles, but what we really want to focus on here is that on the unit circle, the x coordinate is the cosine, so that horizontal leg of the triangles or that horizontal movement. And in this case, it says the cosine of angle or angles should be 0. So we should have 0 horizontal movement. And that only happens in 2 places. So moving from the origin, we have here on the positive part of the y-axis, and also here on the negative part of the y-axis. So to get to these points, we have no horizontal movement, and that's the only place on the unit circle, only those 2 angles. And so this, I think, also emphasizes why we've crossed out reference triangle. We don't need to worry about any of that because we have already sketched in these angles, these quadrantal angles where we have no horizontal movement, and we can just jump right to step 2 in naming these angle answers. So we're going to first name them on the unit circle, or from 0, let's include 0, from 0 to 2 pi. And we can first name this one on the positive part of that vertical axis, of that y-axis. So rotating a half rotation, we should know in radians, is pi over 2. And then if we rotate it almost all the way around to that negative part of the y-axis, that angle is going to be named 3 pi over 2. If you need any help with the naming of these angles, I'll post a link in the video description that goes back to some of those unit circle basics, so you can check out some of those videos for help with getting to know your unit circle really well. So this is our answer. We have theta equals pi over 2 and 3 pi over 2 on this interval from 0 to 2 pi. Substitute them back in. You'll see that when you're checking your answer, you're basically performing exact value calculations. We know both the cosine of pi over 2 and the cosine of 3 pi over 2 are 0. So those check out. One more thing to finish up. Say we had wanted to solve this equation for all solutions. We can write a quick little equation here that gives all solutions. So not just on the interval from 0 to 2 pi, but all the angles that would be coterminal with these. And these angles even have a special relationship. Notice that they're pi apart, or a half rotation apart. So we can write a single equation, theta equals, and we'll start at pi over 2, and we'll say that a solution is going to happen every half rotation, or pi radians apart. So we can say that theta will equal pi over 2 plus pi k, where k is an integer, and then depending on what integer you substitute in, you'll get another coterminal angle that will be a solution. Try it out if you want with k equals 1. We know that pi over 2 plus pi is 3 pi over 2, so we hit that solution that we already named above. But as you substitute in different integers for k, you'll get different coterminal angles, and they all will be solutions to our above equation. So hopefully this helps you out with some solving basics for simple trig equations. Be sure to check those links in the video description. I'll have a lot more worked out examples. So check those out, and thanks for watching.